Distance and displacement are both measurements of length. They use the unit meters. Distance is a scalar. It has no direction. Its symbol is d. Its unit is the meter. And the definition of distance is how far you go in total. Displacement is a vector. That means it has a direction as part of its answer. The symbol for displacement is also a d, just like distance, but the way we tell them apart is because displacement is a vector, it has an arrow above it, d arrow. The unit is also a meter, and the definition is slightly different. It is how far you go, not in total, but from your starting position and which way. Here's an example to illustrate to you the difference between distance and displacement. Imagine a little ant. And the ant makes a long trip wandering around my paper. Not the most efficient route, but here he is. This ant probably in total covered maybe even about 1.5 meters of all of this wiggly distance. It's quite a distance for an ant. We'd call this the distance that it traveled in total. This is distance. It is a scalar because direction didn't factor into what we were doing. The ant traveled all kinds of different directions, but in total it traveled 1.5 meters. The displacement that the ant traveled was its starting position to its ending position, the total covered, and which way. This is a much shorter amount of distance. Even though it did all of this, it only went about this far. Maybe that's about 2 centimeters. Instead of 1.5 meters, it's 2 centimeters, or 0.02 meters. And because displacement has a direction, we would say down. It's 0.02 meters down from where it started. This is displacement. It's how much it's been displaced from where it started. There are 2 methods to determine distance and displacement. You can use either of these methods in any question. It just depends on what feels best for you. There's the diagram method, where you draw a picture, or there's the mathematical method, where you use math. In the diagram, we draw a picture. In the math method, we add all lengths together using negatives and pluses negatives and pluses for displacement. So here's an example where I'll use both methods. A girl walks 5 meters north, then turns and walks 10 meters east, and then walks south 5 meters. What is her distance and displacement? A girl walks 5 meters north, then turns and walks 10 meters east, and then walks south 5 meters. What is her distance and displacement? The diagram method. In the diagram method, we draw a picture. It can help sometimes to use a ruler to make exact measurements. So I'll start the girl here, and I'll use my ruler, calling a centimeter about a meter. So I'll use a scale. So I'm going to have her travel 5 centimeters north to represent 5 meters north. And then she's going to walk 10 meters east, so I'll use 10 centimeters to represent her 10 meters. So that's 5 meters, 10 meters, and then she turns and walks south 5 meters. In the diagram method, we can clearly see she walked all of this distance. So she walked about 5 plus 10 plus 5 is a distance of 20 meters. The displacement she covered is the distance from start to finish. So that is, I'll use a dotted line to show displacement. She walked a displacement of that much. I can either reason my way through it, say, well, this canceled out this, so what's left is equal to 10 meters. But if I did with a ruler and I did it exactly, I can see 10 centimeters across here. Therefore, she must have walked 10 meters. So the displacement is 10 meters, and displacements always get a direction. So I see she's east of where she started, so I say east. That's the diagram method. The math method has us go distance and displacement. In distance, we just add all the numbers together. 5 plus 10 plus 5 equals 20 meters. So for distance, we just added all numbers together to get a total. For displacement, we do the exact same thing. We add all the numbers together, but we look at their directions as well. North, 5 meters north, is a positive direction. 10 meters east, east is a positive direction. So we have plus 5 plus 10. South is a negative direction, so it's plus negative 5. So 5 plus 10 plus minus 5, if you put that into your calculator, makes plus 10. And then because we want a direction and not a sign, we convert it back into a direction. Positive direction is east. So for displacement, we add the numbers just like before, but use signs for directions. Both methods give us the exact same answer. It's just how we got there is different. Example. Here's an example using the diagram method. I'm going to use an ant again. And this ant is going to travel 2 meters, and then go down 1 meter, and then travel across 1 meter, and then it's going to travel down 1 meter, and then it's going to travel forward 2 meters, and then back down 1 meter, and all the way back over 3 meters. This is the trip the ant took. We can clearly see the displacement, or the distance, is all of these little distances added together. 2 plus 1 plus 1 plus 1 plus 2 plus 1 plus 3 makes a total distance of 11 meters. Displacement we find by looking at the starting point and the ending point and finding the distance between them. We have 1, 2, 3 meters, so it's 3 meters, and the direction is south of where it started. So for displacement, you add all the distances that it travels together. For distance, you add all the distance it travels together. For displacement, you find the start point and the end point and find out how far they are apart and which way. And finally, an example using the mathematical method. A cat walks 15 meters north, then turns and walks 20 meters south. What is the cat's distance and displacement? For distance, mathematically, we just take all the numbers that we see and add them together. So 15 plus 20 equals 35 meters. Displacement, we can also do mathematically by adding them together, but we leave spaces for the signs. North is a positive direction, so we say plus 15. South is a negative direction, so we say negative 20. Plus 15 plus negative 20 is negative 5 meters. Convert the sign into a direction. South is a negative direction. So we take the negative and turn it back into a south to finish the problem.